Starting with number 1, Fokker E.III Eindecker, Germany, 1915. The Fokker E.III emerged from Germany in 1915 as one of the first purpose-built fighters, and it was cheap almost by accident. Built from wood, wire, and dope fabric, it cost a fraction of later steel frame designs and could be produced quickly as the Western Front demanded replacements faster than factories could deliver them. Its role was simple: clear enemy reconnaissance aircraft from the sky using a synchronized machine gun firing through the propeller arc, a technical breakthrough that briefly gave Germany air superiority. But the airframe was fragile, the controls heavy, and structural failures in dives were common. Pilots who mastered it thrived during the so-called Fokker scourge, yet as Allied designs caught up, the E.III's thin margins for error left many novice flyers with no room to recover from combat damage or pilot error. Number 2, Polikarpov I-16, Soviet Union, 1934. The Polikarpov I-16 entered Soviet service in 1934 as a stubby, barrel-shaped monoplane built for mass production above all else. Its simple wooden and metal structure kept costs low enough for the Soviet Union to field it in the thousands, first over Spain during the Civil War and later against Japanese forces at Kok-in-Gol. Its short fuselage gave it exceptional agility, but made it notoriously unstable, demanding constant correction from pilots who had little margin for hesitation. The manually retracting landing gear required physical effort mid-flight, a flaw that cost precious seconds in combat. When Germany invaded in 1941, thousands of I-16s were destroyed on the ground and in the air within weeks, their aging airframes outclassed by faster German fighters. Survivors described it as an aircraft that punished inexperience severely, a cheap tool that demanded an expensive level of skill to survive in. Number 3, Messerschmitt Bf 109, Germany, 1937. Germany's Messerschmitt Bf 109, introduced in 1937, was engineered from the outset for efficient, low-cost mass production, using a small, lightweight airframe built around a powerful engine. It became the backbone of the Luftwaffe across every theater, from the Battle of Britain to the Eastern Front and North Africa. That same compact design created a narrow, tricycle-esque landing gear track that made ground handling treacherous, and hundreds of aircraft were lost to takeoff and landing accidents rather than enemy fire. Cockpit visibility was poor, especially on approach, and the cramped canopy restricted a pilot's view during dogfights. As the war dragged on and quality control declined under wartime pressure, engine reliability suffered further. Despite over 34,000 built, a striking number succumbed to accidents, and veteran pilots often admitted more fear toward landing the Bf 109 than toward the enemy waiting above them. Number 4, Yakovlev Yak-9, Soviet Union, 1942. The Yakovlev Yak-9 arrived in 1942 as the Soviet answer to wartime scarcity, built with a wooden rear fuselage and metal wing spars to conserve strategic aluminum. It fought across every major Eastern Front campaign, from Stalingrad to the liberation of Eastern Europe, valued for its low production cost and simple maintenance in brutal field conditions. Its lightweight construction gave it strong low-altitude performance, but the wooden components were vulnerable to moisture and combat damage in ways metal airframes were not, and battlefield reports noted structural failures after prolonged exposure to wet conditions. Cockpit heating and pressurization were minimal, leaving pilots exposed to extreme cold at altitude during winter operations. Still, its low cost meant the Soviet Union could replace losses rapidly, and that industrial resilience, more than any single technical virtue, helped it wear down a technically superior but dwindling German fighter force. Number 5, Mikoyan Gurevich MiG-15, Soviet Union, 1949. The MiG-15, introduced in 1949, proved that a cheap airframe paired with a stolen engine design could rival the best the West had built. Its swept wing and simple riveted metal construction made it inexpensive to manufacture across the Soviet Union, China, and Allied nations, and it became the primary threat over Korea. Yet its rudimentary hydraulic controls made high-speed maneuvers punishing on pilots, and it suffered dangerous spin characteristics that claimed aircraft even without enemy involvement. It lacked an ejection seat in early variants, and pilots forced to bail out at high speed faced serious injury or death from the slipstream alone. Against the American F-86 Sabre, the MiG-15's raw power often outmatched Western aircraft in a straight climb, but inexperienced pilots frequently lost control in a turning fight, turning a formidable machine into a coffin for those who had not trained enough hours in it. Number 6, Folland Gnat, United Kingdom, 1959. Britain's Folland Gnat, introduced in 1959, was designed deliberately as a lightweight, low-cost fighter at a time when Western air forces were building ever larger and more expensive jets. Its small size kept manufacturing and operating costs down, and found its most significant combat role not with the Royal Air Force, but with India, where it earned a fearsome reputation against Pakistani F-86 Sabres in 1965 and 1971. That same compact airframe, however, gave pilots a cramped cockpit with limited instrumentation and demanding handling at low speed, where a moment's inattention could stall the aircraft during a turning engagement. Hydraulic control failures were a recurring maintenance concern, and several were lost to systems failures rather than combat. Even so, Indian pilots nicknamed it the Sabre Slayer, proof that a cheap airframe, flown with skill and aggression, could still humble aircraft that cost far more to build. Number 7. Mikoyan Gurevich MiG-21, Soviet Union, 1959. The MiG-21, entering service in 1959, became arguably the most widely produced supersonic jet in history precisely because it was so inexpensive to build and maintain. Its narrow fuselage and delta wing kept production simple, and it was flown by dozens of air forces from Vietnam to the Middle East. In Vietnam, North Vietnamese pilots used its speed and simplicity to strike quickly against American strike packages before disengaging. But that same austere design meant limited radar capability, poor cockpit visibility to the rear, and fuel systems that left little margin for extended combat maneuvering. Pilots operating at the edge of its performance envelope in humid, high-heat conditions reported frequent engine flameouts, and accident rates in several operating nations remained high for decades. Still, its rock-bottom cost meant it could be replaced almost as fast as it was lost, making it a defining fighter of the Cold War's periphery. Number 8. Northrop F-5 Freedom Fighter, United States, 1962. The Northrop F-5, introduced in 1962, was built specifically under an American program to give Allied nations an affordable, easily maintained supersonic fighter without the complexity of frontline American jets. Its simple twin-engine design and low operating cost made it popular across Asia, Latin America, and the Middle East, where budgets could not support heavier aircraft. Its light armament and modest radar limited it against more advanced opponents, and in aggressor training roles with the United States Navy, its small size made it deceptively difficult to spot, a trait that occasionally contributed to mid-air collisions during dissimilar air combat training. Structural fatigue in aircraft flown hard for decades became a growing concern for smaller air forces lacking funds for deep maintenance. Even so, its low cost and forgiving handling meant that nations with limited defense budgets could sustain a credible fighter fleet for generations after wealthier air forces had moved on. Number 9. Chengdu J-7 China, 1966. China's Chengdu J-7, a licensed and later reverse-engineered derivative of the MiG-21, entered service in 1966 and became a cornerstone of low-cost air power for Beijing and its export customers. Its stripped-down avionics and simple structure kept unit costs far below Western equivalents, appealing to nations across Africa and South Asia seeking supersonic capability on limited budgets. That simplicity came at a price. Early radar and weapon systems lagged years behind contemporary Western fighters, and the aircraft's narrow landing gear track made crosswind landings especially hazardous for less experienced pilots. Accident rates in several export air forces remained a persistent concern, particularly during high-tempo training. Chinese and Allied pilots often described it as unforgiving during approach, where small misjudgment could end in a runway excursion. Its enduring value was never technological superiority, but sheer affordability, keeping aging fleets flying decades after most contemporaries had been retired elsewhere. Number 10. Aero L-39 Albatros, Czechoslovakia, 1972. Czechoslovakia's Aero L-39 Albatros, introduced in 1972, was conceived primarily as an inexpensive jet trainer but was quickly adapted into a light attack fighter across the Eastern Bloc and beyond, prized for its low fuel consumption and simple maintenance compared to frontline combat jets. It saw action in regional conflicts across Africa and the Middle East, often flown by air forces unable to afford dedicated strike aircraft. Its light payload and limited defensive systems left it vulnerable when pressed into roles it was never designed for, and several were lost to ground fire during low-level attack missions where survivability was never part of the original design brief. Pilots transitioning from trainer duties to combat sorties often found themselves underarmed against modern air defenses. Its enduring popularity came from cost rather than capability, a jet built to teach flying that ended up teaching some nations the price of underestimating anti-aircraft defenses. Number 11. IAI KF-IR, Israel, 1975. Israel's KF-IR, introduced in 1975, was born from necessity after a French arms embargo cut off Israeli access to Mirage engines, pushing Israeli aircraft industries to fit an American engine into a modified Mirage airframe at a fraction of the cost of developing an entirely new fighter. It saw combat protecting Israeli airspace and was later exported to nations across Latin America seeking an affordable, capable jet. Its delta-wing heritage gave it strong high-speed performance but limited low-speed handling, and pilots reported it required unusually precise throttle control during landing approaches, particularly in hot climates where engine performance degraded. Several export operators experienced accidents linked to unfamiliarity with its demanding approach speeds. Despite these challenges, its low relative cost let smaller air forces field a genuinely supersonic interceptor, proving that necessity, more than budget alone, can produce an aircraft that punches well above what its price tag would suggest. Number 12. Saab 105, Sweden, 1966. Sweden's Saab 105, entering service in 1966, was designed around neutrality-era economics, giving the Swedish Air Force an inexpensive jet that could train pilots and, when needed, strike as a light attack aircraft, reducing the need for separate specialized fleets. Its twin small engines and simple side-by-side cockpit kept costs low, and Austria later adopted it as its primary jet trainer and light fighter for decades. Its limited engine power meant poor performance at high altitude and in hot conditions, restricting its usefulness in the interceptor role it was sometimes asked to fill. Structural fatigue, after decades of intensive training use, became a growing safety concern for Austrian operators in its later service life. Pilots valued its docile handling for training, but recognized its limits the moment genuine high-performance combat maneuvering was required, a reminder that an aircraft built to be affordable to fly often cannot also be built to fight at the very top of its class. Number 13. JF-17 Thunder, Pakistan/China, 2007. The JF-17 Thunder, a joint Pakistani-Chinese program reaching service in 2007, was built explicitly to give Pakistan a modern multi-role fighter at a cost far below Western alternatives, replacing aging fleets that had become too expensive to sustain. It has since flown operational patrols along contested borders and been exported to nations seeking capable jets without the price tag of American or European equivalents. Its lower-cost radar and avionics suite, while continually upgraded, still trail the sensor fusion of more expensive contemporaries, leaving pilots reliant on close coordination with ground control in contested airspace. Early production aircraft faced scrutiny over engine reliability during high-tempo operations, and export customers have had to weigh spare parts availability against the aircraft's attractive price. Even so, its affordability has allowed air forces with modest budgets to field a genuinely modern fighter fleet, continuing a century-long pattern where the cheapest aircraft, not the most advanced, often decides who controls the sky over a nation that cannot afford anything more. Number 14. Hawker Hurricane, United Kingdom, 1937. Britain's Hawker Hurricane, introduced in 1937, used a fabric-covered rear fuselage over a steel tube frame rather than the stress-skin aluminum construction of its Spitfire counterpart, a deliberate choice that kept production cost and complexity far lower during a period when Britain desperately needed numbers over sophistication. It bore the brunt of the Battle of Britain, shooting down more enemy aircraft than any other Allied fighter that summer. Its slower top speed and heavier airframe left it at a disadvantage against German fighters at altitude, forcing squadrons to concentrate Hurricanes against bombers while Spitfires engaged escorts. Fabric skin also proved more vulnerable to fire, and burn injuries among Hurricane pilots became a defining, tragic feature of the campaign. Even so, its simple construction meant damaged airframes could be repaired quickly at forward airfields, keeping squadrons flying when a more advanced design would have been grounded for weeks awaiting parts. Number 15. Curtiss P-40 Warhawk, United States, 1940. The Curtiss P-40 Warhawk, entering American service in 1940, relied on an existing engine and a conventional airframe designed to reach production quickly and cheaply at a moment when the United States needed fighters in massive quantity rather than cutting-edge performance. It fought across North Africa, China, and the Pacific, most famously with the American volunteer group known as the Flying Tigers. Its lack of a two-stage supercharger left it badly outperformed at high altitude, where Japanese and German fighters could dive away from engagements at will. Pilots learned to avoid climbing fights entirely, using the P-40's sturdy airframe and diving speed instead, a tactic born directly from the aircraft's technical limitations. Losses to more agile opponents in sustained turning fights were significant early in the Pacific War. Its enduring value came from ruggedness and sheer production volume, not raw performance, keeping Allied air power present when better aircraft were still years from the front line. Number 16. Mitsubishi A6M0, Japan 1940. Japan's Mitsubishi A6M0, introduced in 1940, achieved extraordinary range and agility partly by omitting armor plating and self-sealing fuel tanks, a deliberate weight-saving decision that kept the airframe light, and its production demands manageable for Japan's limited industrial base. It dominated the early Pacific War, escorting bombers across vast ocean distances no Allied fighter could match. That same lack of protection made it dangerously vulnerable once hit, and pilots described how a handful of rounds into the fuel tank could turn the aircraft into a fireball within seconds. As American tactics adapted and newer fighters like the Hellcat entered service, zero losses climbed sharply, and by 1944 experienced Japanese pilots had grown scarce, replaced by trainees flying an aircraft that offered them no margin for survival if hit. Its early triumphs were built on a trade Japan could not sustain once the war turned into one of attrition rather than maneuver. Number 17. Nakajima Ki-43 Hayabusa, Japan 1941. The Nakajima Ki-43 Hayabusa, entering Japanese Army service in 1941, followed the same philosophy as the Zero, trading armor and structural strength for lightness and remarkable agility, keeping unit costs and material demands low for an already strained wartime economy. It fought across Burma, China, and the Pacific Islands, prized by pilots for its tight turning radius in close-range dogfights. Its light wing structure proved prone to failure during high-speed dives, and several aircraft suffered wing separation when pilots pushed the airframe beyond its rated limits while trying to escape faster Allied fighters. As American aircraft grew heavier armed and better protected, the Hayabusa's lack of armor left pilots exposed to fire that a sturdier design might have survived. Veteran pilots respected its handling, but increasingly feared engagements where raw firepower, not maneuverability, decided the outcome, a mismatch that grew starker as the war progressed toward its final years. Number 18. CAC Boomerang, Australia, 1942. Australia's CAC Boomerang, rushed into service in 1942, was designed and built domestically using components from existing trainer aircraft because Australia had no time or industrial capacity to develop something more advanced while Japanese forces advanced through the Pacific. It served primarily over New Guinea, valued less for air combat than for close air support and forward artillery, spotting once faster Allied fighters had arrived to handle aerial threats. Its underpowered engine left it unable to compete with Japanese fighters at altitude, and it was quickly relegated away from air-to-air combat after early encounters proved costly. Pilots recognized quickly that engaging enemy fighters directly was a losing proposition, and squadrons adapted by using the Boomerang's low-altitude agility for reconnaissance and ground attack instead. Built out of urgent necessity rather than ambition, it never became the aircraft its designers hoped for, but it kept Australian air power present during the war's most uncertain months. Number 19. Yakovlev Yak-3, Soviet Union, 1944. The Yakovlev Yak-3, refined and mass-produced by 1944, stripped the earlier Yak design down further, removing fuel tanks and non-essential equipment to reduce weight and cost while concentrating performance at low altitude where most Eastern Front combat actually occurred. Soviet pilots used it extensively during the final offensives into Germany, where its light weight gave it exceptional turning ability against German fighters. That same reduced fuel capacity limited its range and endurance severely, forcing missions to stay close to friendly airfields and leaving little reserve if a pilot became disoriented or damaged far from base. Its lightweight wooden components again proved vulnerable to prolonged wet weather, a persistent limitation inherited from earlier Yak designs. Despite these constraints, its low production costs let the Soviet Union field it in overwhelming numbers during the war's final year, trading range and durability for a fighter that could be built and replaced faster than Germany could counter it. Number 20. Shenyang J-6, China, 1958. China's Shenyang J-6, a licensed and later independently produced version of the Soviet MiG-19, entered service in 1958 and became the backbone of Chinese air power for decades due to its low-cost and straightforward manufacturing process suited to China's developing industrial base. It saw combat during border skirmishes and was exported widely to nations in Africa and Asia seeking an affordable supersonic fighter. Its early radar and weapon systems lagged well behind contemporary Western fighters, and its afterburning engines were prone to compressor stalls during aggressive maneuvering, occasionally causing flameouts in combat conditions. Several export operators reported high accident rates tied to engine reliability and demanding handling characteristics at low speed. Pilots often described it as powerful in a straight line, but unforgiving of mistakes during landing, where a narrow gear track punished any lapse in crosswind technique. Its lasting legacy was volume and affordability rather than technological sophistication, a formula that kept it in frontline service in some air forces into the 1990s. Number 21. PZL Lim-2, Poland, 1952. Poland's Lim-2, a domestically built version of the Soviet MiG-15, entered service in 1952 as part of a broader Warsaw Pact strategy to license-produce Soviet designs cheaply across Eastern Europe rather than fund independent fighter development in every Allied nation. It formed the backbone of Polish air defense through the height of the Cold War, valued for parts commonality with other Soviet-aligned air forces. Its early ejection systems and cockpit pressurization were rudimentary, and pilots flying at altitude in Poland's harsh winters reported cases of frostbite and disorientation during prolonged patrols. Structural fatigue became a growing concern as airframes aged well past their intended service life, since replacement aircraft were prioritized for larger Soviet allies first. Polish pilots often flew airframes considered obsolete years before newer aircraft arrived, a direct consequence of a licensing arrangement built for cost efficiency rather than for the specific needs of the country actually flying them. Number 22. Aero L-29 Delfín, Czechoslovakia, 1963. Czechoslovakia's Aero L-29 Delfín, introduced in 1963, was selected as the standard jet trainer across the Warsaw Pact specifically because its simple, rugged design could be built and maintained cheaply across Allied nations with varying levels of technical infrastructure. Though designed for training, several operators pressed it into light attack roles during regional conflicts in the Middle East and Africa, where dedicated strike aircraft were unavailable. Its modest engine power and limited weapons capacity left it dangerously exposed when used against modern air defenses, a role its designers never intended for it. Pilots transitioning from advanced training directly into combat sorties in the L-29 often lacked the systems and firepower to survive contested airspace, and losses in improvised attack missions were disproportionately high. Its true value remained in the training pipeline that produced generations of Eastern Bloc pilots, a reminder that an aircraft built purely for affordability rarely survives well once asked to fight. Number 23. HAL HF-24 Marut, India, 1967. India's HAL HF-24 Marut, entering service in 1967, was developed domestically to reduce India's dependence on costly foreign fighter imports, using German design expertise, but built and powered with resources India could sustain independently at the time. It flew ground attack missions during the 1971 war with Pakistan, valued for its rugged airframe in the strike role. Its intended afterburning engine was never fully developed due to funding and technical constraints, leaving the aircraft permanently underpowered relative to its original design goals and limiting its performance against contemporary fighters. Pilots described a persistent gap between what the airframe promised aerodynamically and what its engines could actually deliver, a frustration that shaped its entire service life. Several were lost during low-level strike missions, where the lack of raw power reduced options for evasive maneuvering under fire. It remained in service for its low relative cost rather than its performance, a fighter defined as much by the engine it never received as by the one it had. Number 24. EMBRAER EMB-326 Xavante, Brazil, 1971. Brazil's EMB-326 Xavante, a license-built version of the Italian Aermacchi EMB-326, entered service in 1971 as an affordable light attack and training aircraft suited to a developing aerospace industry still building its own design capability. It served across Brazil and was exported to Allied South American air forces seeking a low-cost strike option. Its limited payload and unpressurized cockpit restricted operations at higher altitudes, and its modest defensive systems left it vulnerable during ground attack missions flown at low altitude directly into small arms and anti-aircraft fire. Several were lost during counterinsurgency operations where its slow attack speed gave ground defenses time to track and engage it accurately. Pilots accepted these risks because it was often the only jet-powered option their air force could afford in sufficient numbers, a pattern repeated across smaller air forces worldwide, where the aircraft that could be bought outnumbered the aircraft that could truly survive the missions assigned to it. Number 25. CASA C-101 Aviojet, Spain, 1983. Spain's CASA C-101 Aviojet, entering service in 1983, was designed to give the Spanish Air Force an inexpensive jet trainer that could also perform light attack duties, reducing the need to purchase separate specialized aircraft during a period of constrained defense budgets. It was exported to Chile, Jordan, and Honduras, nations seeking a capable but affordable jet for both training and limited combat roles. Its modest engine thrust restricted performance at higher altitudes and warmer climates, a limitation felt acutely by operators in Central America and the Middle East. Its light armament left it outmatched whenever pressed into genuine air-to-air roles it was never designed to fill, a mismatch some export customers encountered directly during regional tensions. Pilots valued its docile handling for building flight hours, but understood clearly where its limits lay the moment a mission demanded more than the airframe was ever built to provide, closing out a century-long story where the price of a fighter has always shaped the price its pilots paid to fly it. If you enjoyed this video, don't forget to subscribe and hit the like button for more military aviation history. Thanks for watching this video. See you in the next one.